In this video, we are going to find positive integers x and y such that 2 to the power x plus 17 equals y to the power 4. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. As we are given that x and y are both positive integers, that means this number, the exponent is at least 1. So 2 to the power of that number is at least 2, and so that means it's an even number in particular. Now from this we know that y to the power 4 is an even number plus 17, and so that means it has to be an odd number. And this also implies that y has to be odd as well. Next, I'm going to consider the remainder when both sides are divided by 17. So for the left, the plus 17 can be ignored, and so we only have to take care of the 2 to the power of x. Notice that 2 to the power of x is either congruent to, starting from x equals to 1, we have 2, 4, 8, 16. For 16, we can rewrite that as minus 1 instead when we consider mod 17. Next, we have minus 2, and that's 15, minus 2, minus 4, minus 8. And equivalently, they are 13 and 9 mod 17. Of course, for the next one is 1 mod 17. So these are the possible values. Whereas for y to the power 4, it's either congruent to, starting from 1 again, I'm just writing out the exact values for the fourth powers. Up to 8 to the power 4. Notice that starting from y equal to 9, say when y is 9, 9 to the power 4 is actually just congruent to minus 8 all to the power 4 mod 17. And that's exactly the same as 8 to the power 4 mod 17. So I'll just stop when y equal to 8. For each powers, the remainders are minus 1, minus 4, 1, minus 4 again. For 6 to the power 4 is actually 4. 7 to the power 4 gives 4 mod 17. And finally for 8 to the power 4 we get minus 1. So these are the remainders when the fourth powers are divided by 17. Looking at the results mod 17, the only occasions when they are congruent to each other is, say, when the remainder is 4 or minus 1 or minus 4, or when the remainder is 1. And the pattern at the side of 2 to the power of x is that when x is an even number. So from this we can conclude, a very important conclusion is x is an even number. So I can let x equals 2k some positive integer k. And now we go back to our original equation, which is 2 to the power 2k plus 17 equals y to the power 4. The fact that x is even is important because then we can use difference of squares. So we have this, and we can factorize. Now since y squared plus 2k is positive, this part is positive, the other part has to be positive. So we can just say that the highlighted part is 17, exactly 17, and the other part is exactly equal to 1. This is because 17 is a prime number, and this is the only combination that two integers multiply can give 17. So solving, y squared equal to 9, 2 to the power k equals 8. And so y equals 3 or minus 3. Of course, we reject the negative case because we assume that y has to be positive. Whereas for 2 to the power k equals 8, and we have k equals 3. So that means, therefore, the only solution is when x is 2 times k, that's 6, and y is equal to 3. Of course, we can do some checking, which is 2 to the power of x plus 17 is then equal to 81, and that's equal to 3 to the power of 4. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.